Hey guys, most of you know Adrian Weber. He's a big-time collector and supporter of the lock sport community. And about a month ago in Germany, where he lives, a gravel truck rear-ended his car and it kind of injured him and just totally destroyed his car. Anyways, he's been recovering. He and I have been talking about the perfect pinning tray, or his idea of the perfect pinning tray. And so I asked him to send me some of his ideas, and this is what he came up with. Kind of difficult because it's from a photograph that he emailed to me, but his idea is just to have a pinning tray where your tweezers fit on top somewhere, a couple of slots to hold different tools, parts of the lock, and then a special little tray to hold the core with the key in it. Sometimes you don't want that falling over, and then of course the places for the pins. And after he sent this to me, he followed it up with a somewhat detailed drawing. He wants it made out of aluminum. He called this pinning tray version 1. And he wants his logo on the top, place for the tweezers, and then longer tweezers or springs here. And then for some reason he wanted 8 different pinning slots. I don't know why 8. I think 7's probably more in line with what we're likely to find. And then instead of a long tray like you see here and like most of our pinning trays have, he decided he wanted to have separate slots, one for the spring, the key pin, the drivers, and then any master pins, master wafers to go inside of there. And then he didn't know the exact location, kind of put a question mark there, leave it up to me. He really hadn't decided on that. And then more parts, bigger parts or whatever go over here. So that's kind of what he came up with. The dimensions are kind of way off. Anyway, I got to looking at this, and I figured since Adrian's had such a tough time of it lately, I'd see what I could come up with. So let me show you what I came up with. Alright, before we get started, I'd like to give a quick shout out to Keith for recommending this software. I'd been using Autodesk 123 Design. You guys have seen that before. But Keith told me that SolidWorks was much more capable, and being a mechanical engineer myself, I found that I didn't quite have the flexibility I did in the other program, in the 123D Design. So when I got SolidWorks, I convinced my wife it was, quote, an investment, unquote, and I told her it only costs $100, which I don't know if she believed me or not. Anyway, getting back to this is much more capable. The first thing I did was kind of dimension properly what I thought the pinning tray should be, and then the first thing I did is went ahead and put in the 7 different rows of the different compartments for Adrian's. And with this program is pretty cool because now if you look closely at this, I'll zoom in just a little bit on this. You can see that this really did allow me to chamfer these edges, round them all off. So when we put a pin in there, if we have to get it out with our finger, it won't be hard to do. Nothing's squared off. It'll just kind of roll right off into our finger. So I thought that was kind of a useful thing. So now that that's in place, now let's figure out how we're going to put all the other things in. Alright, before we began this, I had taken some measurements of my own tweezers, and I figured out that given the area that we had to work with, they would fit perfectly. That's why I chose the width of this tray. So there we go. We have the tray cut for the tweezers. You can see that I've also rounded all the edges. I hate square edges, and so it's rounded. It'll make it easier to keep it clean, and if you really want to get a look at what this thing will look like in real life, there you go. So all rounded. We have a slot cut in there for our tweezers now. So now let's go back and keep adding things and get everything that Adrian wanted. Alright, the next thing I decided to go to work on was this tray cutout. Now in Adrian's picture, he shows a very unique shape for this. In fact, he even in the photograph that he sent me used a core, but the problem is a lot of cores are different, and if I were to cut it to the exact dimension of that, it wouldn't fit. I do want a slot so that the key can sit vertically, so the key can sit in there, the pins will remain in place, and it won't tip over and all the pins fall out. So that's what this slot is for. Let me go ahead and go to the production view, and now you can kind of see what it is I'm talking about. There's a cut in the side there. I'll zoom in on that, and I've also got everything rounded off very neatly. Again, got to get away from those sharp edges. And then I just kind of use a generic tray. I tried a lot of different sizes. I got a lot of cores here in the Lock Lab, but I just decided to take the biggest core that I had and make the slot to fit it, because we never know what we're going to be working with. So we got that in. Let's keep going to see what else we can put in for Adrian. Alright, the next thing I added was this tray that you see here on the bottom. I decided one larger tray would be better than a couple of small ones. I don't know why. It just seemed like it would fit better and be more aesthetically pleasing anyway. Here's a production view of what this thing will look like. Again, kind of rounded everything off. You can see that so we put some parts in there. We can easily roll them out with our finger. Nothing's going to get caught up, trapped in a corner, for example. So anyway, that's what we got so far. Let's go ahead and finish this thing off. Okay, in this angle, the production view doesn't look a lot different, but when I put the cursor up there, you can see I've inserted the security elements. And what we'll do, we'll go to a different view here, a little bit from a forward angle, and now you can see it's got security elements engraved. It's 2 millimeters deep on there, so it won't be easily damaged or scraped off. So anyway, there's what we got so far. Why don't we take this thing and convert it? Now the beauty of this program is that it speaks a lot of different languages. I can translate this into something that my 3D printer will understand and translate into a solid object. It can also translate it into other, I guess you call them languages, other file formats, so that we can produce a file for a CNC machine, so that all you do is put in a blank piece of aluminum, plug in the code, and it will generate this in pretty much any metal you like, aluminum, stainless steel, or whatever. But for now we're going to stay with plastic because that's all I have to work with. So let's take this, export it into a file for my 3D printer, and see if we can't make it happen. Alright, the next step is to actually import this thing into the Makerbot software so that we can make a couple of last-minute checks. The main check, of course, is to make sure it's going to fit on the printing surface. We can make sure it's, the angle and everything is correct, and you can see it does. We could move this thing around and rotate it, but it imported perfectly, so we don't need to do that. So this is what it's going to be looking like on the platter when we begin to print. So let me export this to a chip, and we'll start printing. Alright, now comes the most important part of the whole project. Selecting the color. Now, of course we got a lot to choose from here, and my first instinct, knowing Adrian's favorite color happens to be pink, I'm very tempted to grab that, but just to try something a little bit different. It's winter in Germany right now, gray weather. Let's try out this battleship gray. So let me hook that up and see what we can do with it. Okay, the gray filament's all loaded up, and from this point on, all the work depends on the machine. All we do is we highlight Build from SD, we select Adrian's tray right there, and we click Go. And from this point forward, the machine takes over. Alright, first thing he's going to do is lay down the foundation for Adrian's picking tray, and then he's going to start doing all of the infill. And no point in filming all of that. You guys have seen this thing work in fast motion before. This will take about 5 hours. I'll take occasional short clips as it progresses through it. Right now we're starting the very first diagonal. Okay, now it's gotten down the first base layer. We're putting in the second layer. You notice it's going in a different direction to reinforce the structure of this thing. So it'll be very, very strong. By the way, this is plastic. It's called ABS. It's the same stuff that Lego is made out of. Very, very tough material. Also doesn't corrode when we get solvents and lubricants like WD-40 on it. Anyway. Okay, we're about an hour into the print, but this is probably one of the more interesting parts of the print job. What has happened is, in order to save material, this ABS it can be quite expensive. It's honeycombing the inside of it, so you can choose the infill. So the inside of this thing is going to be virtually hollow, other than this honeycomb reinforcement. And then we're going to print, as you can see here, we're starting to print the foundation for the working tray and for the lock pinning tray, the core tray. Alright guys, 5 hours and 17 minutes later, that's how long it took to print this thing, but it came out beautifully. Just exactly the way the drawing intended. Very solid, very durable. We got our slot up here for our tweezers, and by the way, they just fit in there perfectly. Places for pinning, we can put our parts there, and then if we want to set our lock over here, we can set it with that key sitting in that slot. So let's go ahead and set it up and make sure everything works. Alright, I gotta say it turned out pretty well. The slot for the tweezers fits perfectly. Got a little bit of extra room in there, but that's okay. The pinning tray, I've noticed that the slots are just, well, they're not bad. The pins can be pulled out fairly easily with your finger. I do like the rounded beveled edges. What I have to say is they might be a little bit wide. We could probably get away with making these a little bit narrower next time and save some space on the pinning tray, the actual size of it. The parts tray, what can I say? It's going to work. What can go wrong with a parts tray? But one of the beauties of prototyping is that while something looks good on paper and the idea sounds wonderful, when you actually manufacture it, it doesn't work so well. And that's the case with this pin. Now, at first I agonized over the width of this. I just measured a regular key, but then some keys have this plastic head on them, and so I decided to make it wider so to accommodate the plastic head. But now you'll notice it when we use a larger core, it kind of angles up. And it's going to be hard to show at this angle, but it doesn't sit flat. It sits a little bit cockeyed on here, which isn't real stable. What I think would have been a better idea is to extend this cut all the way through the tray, give us a little bit more extra room, and it would make the core sit in there a little bit more, give it a little better stability. Anyway, all in all, I think it's a great idea. This is the beauty of prototyping. I mean, it really took us from the time that I received, this rough drawing to convert it into the digits for the computer to put it into SolidWorks and then actually print it out using a 3D printer, all less than 24 hours. Probably closer to 12 hours. And a lot of that, 5 of it, was printing it. So it's not that big of a time investment to discover you've got a design defect, as I believe we probably do here. So we'll make that minor correction, and then as far as I'm concerned, Adrian's pinning tray will be just about perfect. Anyway, Adrian, I'm going to drop this in the mail to you. Everybody else, thanks for your patience and putting up with me giving very over-detailed explanations of what's going on, but I thought it was interesting, and I hope you do too. Everybody stay safe and stay legal.